Okay. I think this has started recording. So good afternoon. Thanks for coming. Today I want to make a short presentation, but what's more important is I'd like to get your ideas, opinions, questions about this. So at Northeastern, first of all, I'm going to start about talking about big data, what kind of challenges you can have with big data. And then I'm going to talk about the discovery cluster and how they can help you. And then we're going to go briefly over the discovery channel, discovery cluster structure. And then I'm going to show you how to get started and how to use it day to day in your research. I'm also going to show you, make a demo, how to log in and how to run something the way I do it. And then, your questions are very interesting to me. Okay, so now how do you know you have big data? You know you have big data when your computer freezes, okay, and or just gives up. And I personally have experienced this a number of times. I'm sure you might also have. So sometimes the memory requirements are too big, so your computer will not have enough memory, okay? So that may prevent you from solving your problem. Sometimes the CPU computations could take a long time, and sometimes you may have a lot of read-write input-output, okay? So desktops have limitations, and the discovery cluster can solve all of these problems. Okay, we have a huge computing power there. And what this can be useful is, of course, our research, but I think in addition to our research, increasingly our students will be exposed to this kind of thing in their work. So I think we can incorporate some of this in our teaching, so that our students will be better equipped for the real world. So where's the discovery cluster? The discovery cluster is here in this building, okay? This building is in Holyoke, Massachusetts. It's called Massachusetts Green High Performance Computing Center. It's a $100 million building. And the reason it's not on campus or elsewhere is because of cheap electricity. Okay. Very good. It's actually owned by five universities. University of Massachusetts, MIT, Harvard, Boston. They all share this building and the computing facilities there. Okay. So the discovery cluster is physically located there, but we can connect to it through remote connection from our desktops, okay? And what's even more convenient is we have support staff at the university on campus who can help us with this, okay? So we don't have to go to Holyoke or off campus. Okay. All right. So what's in the cluster, or what's a cluster? Okay, a cluster is a collection of queues. Okay, what is a queue? Well, a queue is a collection of nodes. But then what is a node? Node is a collection of processor cores. Okay, so on our desktops we can have dual core processors or quad core, etc. So they have these cores, okay, and they have grouped them into nodes, okay. So for example, I'm going to show you nodes with 40 cores, okay, and then you have multiple cores like that. Multiple nodes like that, and then you'll have the nodes in queues, okay. So when you use the discovery cluster, what you do is you go into a queue and you look at the available nodes, that are not being used. And then you just request one of the nodes. And when you get one of the nodes, you get all these cores, processors. And of course, the idea is parallel computing. So I'm sure you all know what it is, but for some of our viewers, what this basically means is that the modern software does this automatically. You don't have to program. So modern software detects how many cores you have, divides up the task, and gives each piece to a single core. So all cores process one portion of the task, and the output is then put together and shown on screen. So the idea is divide and conquer, divide up the task to smaller chunks, and each chunk can be processed simultaneously in parallel, and so things run much faster. Okay, so when you log into the Discovery cluster, you can just get a listing of queues. Okay, so these are the names of the queues. Now, some of the queues, okay, are for use by everybody. Okay, however, some researchers have purchased their own hardware and established their own queues. Okay, so only they can use certain particular queues. For example, this Redwood queue. I don't know who it belongs to, but I'm pretty sure there's a professor named Redwood, and he bought the hardware, and then only he can use that. But other queues is open for pretty much all the faculty and staff.
Hadoop means Hadoop?
Yes, Hadoop, we have interactive, Serpart, 10G, 10G, HT10G. So these are, most of them, like at least this upper half is open to everybody. Okay, so what you do is you just select one of these, whichever one you want, and then you look into its nodes. So I went into nodes 10G. This is Serpart 10G, I think. So it has, I don't know, 30, 40 core, 30, 40 nodes, okay? Yeah, these are compute nodes, compute 66, compute 67, etc. And some of the nodes are closed. Why? Because they have 40 cores, and all 40 cores are taken. Okay, so they're closed. But what you can use is you can use other compute nodes where, for example, this compute 95, okay, has 40 available, but nothing is running on it. So if you request this, you'll get assigned this this node, compute node 95, and you will have this available to you. And when you use it, you don't have to code or program or anything. Modern software detects the number of cores. Okay. Now, when you get the node, how long can you have it? You can have it normally for 24 hours. Now, in my experience, you don't need a particular node for 24 hours. You just do your calculations. Typically, I've used it interactively. You can use it also in a batch mode. Yes?
Suppose I'm going to use Core for 1 week.
Now, if you want to use it continuously for 1 week, then you need to ask the research computing staff. I'm going to come to that, and then they can give you special permission. But usually I log in, do something, and then log out and release the queue.
Because some optimization problems can be very, very time consuming.
Yes, yes.
24 hours might be
Yes.
It should be each time to ask for each run?
Um,
One-time permission?
they have, so if you have a long run, you can ask for that. But what also happens is that at the end of 24 hours, your solution, like the state of your code, is saved. So it doesn't disappear after 24 hours.
Okay,
So
so
even if you haven't asked for extended period of time, after 24 hours, they save whatever has been done so far, and then next time you log in, you can restart from where it was.
so the rest of the same code, I just restart?
Yes.
Or I have to run for a specific program which will deal with it? Do I need to run a specific program?
No, no, no. They have what they're using is a platform called LSF. This is an IBM platform. Okay, so what this does is it manages all these cores and processes. So this runs on top of Linux. Okay, so you know, it's. I mean, we can talk about it in more detail later, but you know, it's completely possible to have extended time. Okay. So okay. So what kind of programs do they have on here? Okay. They have pretty much everything that you can ever need. Okay. So they have MATLAB. A lot of engineering students or professors use MATLAB. They have. I didn't write this down. They have Java. They have Python. You know. They have SAS, Stata, Mathematica. And the beauty of this is when they buy a software, they buy a lot of licenses. So for example, MATLAB has 256 licenses. So 256 people can use this at the same time. Okay? So even if a software is very popular, you know, you can run many instances of that. And if it's not here, you can easily get it installed here. Yes?
So it has R, obviously it's got the R libraries.
Yeah.
But what if I wanted to install my own libraries from R inside my runs?
Yes, that's perfectly possible. I'm going to talk about that. Yes. So how do you get started? Now we have a department on campus that provides free consulting. Okay. So to start, you need to contact them. Okay. This is research computing. Okay. And so they have workshops from time to time, but they have been very helpful to me whenever I go there in person without appointment or anything. They sit down with you, you explain to them what you need, and then they give you a customized solution. Okay. But first, you need to get an account. Now, this is not a new account. It's the same username that you have with MyNEU, same password. Just tell them you want to access this, and then they'll make your username and password able to access the Discovery cluster. So that's how you open an account. Your username doesn't change, password doesn't change. And the contact person is Nilay Roy. Okay. And it's best to sit down with him because some clusters are computationally intensive. Some nodes are computationally intensive. Some of them are memory intensive. So he'll direct you in the right direction. Okay, what type of software you need, what type of hardware you need. Okay. So when you get to a compute node, it's like a blank slate. Okay. There are no software installed. He will write a script for you each time you log in, will install the necessary modules. So you don't have to do it every time. So there'll be a startup script, and if you tell him, okay, I need X, Y, and Z, he'll write the script for that, and every time you log in, those things will be automatically loaded. Okay? So in this case, I used Mathematica, and he just wrote a script, and every time I log in, Mathematica is automatically loaded. Okay. Okay, so once you're set up, you can use your desktop to connect. And if you connect from your office, it's fastest. Okay, it's fastest through a wired network connection. You can also be in your office and do a wireless connection. That's a little bit slower. And the slowest is you can connect from home. Okay, that's the slowest connection. But what you can do is you can start something from your office, log off, go home, and then check on the process from time to time. Okay, so for that you need 3 simple programs. Okay, FileZilla. Okay, FileZilla transfers files between the cluster and your desktop. So you get some results on the cluster, and then you can just download them on your desktop. That's FileZilla. Okay, Xming is for the interactive mode, like a Windows interface. Okay, and the basic connection is through PuTTY. Okay, so let me show you how these work. Okay, on the desktop, the way I do it. Okay, so before I do anything, I ran Xming here, and it's completely in the background. You don't have to do it. Just start it and leave it as it is, and it will be running in the background. So if you click here, so Xming is running in the background. No need to interact. And then I start PuTTY. Okay, this is PuTTY. Okay, so there are some some settings. Okay, and then okay, ignore. Okay, just log in with your my NEU credentials. Okay, so this may take a few seconds or multiple seconds. Okay, so now I've logged in. Okay, and then I can look what nodes are available, etc. I'm not going to go through that. I'm just going to start Mathematica. Okay. So this is my job number. I'm doing something. And see, Mathematica is starting in the background. So I'll just minimize this. Now this is running from the cluster. You don't have to have this on your desktop installed. Okay. So this is Mathematica. It looks exactly like the one I would use on my desktop. And you can open it up and okay, so you would just run this and yes, question?
Yeah. So you didn't in this case sort of choose a queue and a node. It just did that for you behind the scenes when you ran Mathematica?
This time I didn't choose a queue. I mean, I could choose a queue. So right now I'm at the what is called this login node. Normally I should move to a compute node, which I haven't done because I'm not going to do any like heavy weight or heavy duty.
Normally you would say, I want to, from now
Yes.
on, I want this stuff to happen over
Yeah,
here.
Yeah, let's do that. Let's kill this job. So. Okay. So I'm here. Let's look at the good thing about PuTTY is it stores your comments, commands. Okay. So using this command, okay, I select a particular queue and I want to look at the nodes. I click enter and I see, well, these are closed, but then I have some available nodes. Okay. So, and then I would say something like, okay, I want a particular node with so many, cores, and it'll just say, from here you'll move to the compute node, to one of these. It will assign you one of these open nodes. Okay. So, and then every user will get a their own library. So they have what is called the Scratch library. Scratch library, okay? And then within that library you have your own files, okay? So here are some of my files from that library, okay? So these are output files that I generated. They're in comma-separated value format, and then I can download them from here to my desktop. Okay. Yeah.
And I can't quite read that. My eyes aren't that great. So are you just typing Linux commands? Are you just doing like the ls and stuff like that to get these things, or are you? What's the interface here?
Okay. That's okay. To answer that question, thanks for that great question. Yeah.
42. That's the answer. Like,
Yes. Yeah. So, yeah. I mean, let's keep the conversation going even beyond this presentation. Let's get together and exchange ideas.
So I have a background in computers. I know Unix well, unfortunately. So I can, if you're running into stuff, if I can be of help, by all means, let me know. I don't think I need this. I have a fairly high-end server. I don't run into stuff. I doubt I could install my own, UCINO software on this, but have them run it for me.
Yeah.
But it'd be kind of cool to see how fast it is.
Now, I mean, they're single board computers. They're like small boards, and then they have everything just processing, and then they just can link them up, and they can build big servers, and so. Yeah. All right. So, if you have any other questions, just let me know, and.
So, I'm sorry, just back to my previous question about, like, I want to install some other R libraries.
Yes.
Like, they let that happen? Like, I can, or in
Yes.
Stata, if I went in there directly in Stata, and I say, oh, go get me this module from,
Yes.
They don't care about the networking stuff, and they just let stuff download, and they're okay with that?
Like from the internet download? Oh, I'm not sure about that. But I'm sure they have a sanitized version or an approved version for you. So, yeah.
I would imagine that they'd be a little hesitant.
Yeah.
I think they'd be a little, maybe Stata, because Stata's integrated right in the software, they might let it go, but like the R libraries, you can go,
Yeah.
here, have my R library, and who knows what it does, so.
Yeah.
But,
Nilay Roy.
Eli Roy?
Yeah. n.roy@neu.edu. And I'm going to make this available. I'm going to email the slides to everybody.
They'll email us, okay, great.
So,
Because I didn't write down all the software.
yeah.
Started.
Yeah. Yes.
You load and unload this data, for example, using Qt also, or not Qt, right? But you use file zero, right? So you could unload this data
Yes.
So this, yes, suppose one of the files is not on load on your own your desktop.
Yes, you use FileZilla to take this, put it on your laptop or desktop.
Is
Yeah.
it easy enough? Like, package?
Yeah. Yeah, it's all free software. Okay. Yeah. So, and then you just say exit to close this. Or for example, I can see if I run any jobs, if I have anything running, no unfinished jobs. It says no unfinished jobs. If there was something running in the background, I could say be kill. So normally in Linux, I think you say kill. Or so,
kill -9 or something like that.
yeah, but here you say be kill for whatever reason. So, and then you exit like this. Okay.
Have you ever run like Excel? Say it faster.
Yeah, yeah. So.